Alright guys, this is Mr. Thompson here, and today I'm going to be talking to you about another part of the Unit 10 solutions information that we're going over. Today we're actually going to get a little bit into the calculations. We're going to be talking about molarity and dilutions. So let's get started with that. Let's talk about molarity. Well, what is molarity? Molarity is the amount of solute per volume of solvent. It is basically the concentration of the solution. The more stuff we put in there, the more concentrated it is. The less in there, the weaker the solution is. Okay, and we're going to use the unit molar here. So if I refer to something as a 5 molar solution, that means there are 5 moles per liter, basically 5 moles of solute per liter of solution. All right. Now the formula is very simple. It is just the molarity, which is represented with a capital M, is equal to the number of moles divided by the volume of the substance. Okay. Like I said, the unit is molar, so we'll talk about a 3 molar solution, a 2.4 molar solution, and it is represented using a capital M. Now, usually we're going to use water as the solvent, although there are times when it may be otherwise. But for now, when we talk about adding or subtracting solvent from something or something like that, we're talking about water. All right, so let's jump right into some examples. Let's take a look at some calculations. What is the molarity of a 2.6 liter solution that has 1.97 moles of solute? This is real straightforward. It's straight off the formula. 1.97 divided by 2.67, and we get 0.738 molar. That is a 0.738 molar solution. Okay, please make sure you don't confuse this. It's not 0.738 moles. It's a 0.738 molar solution. Okay, let's take a look at another example. We have a beaker with 500 milliliters of a 10 molar nitric acid. How many moles of nitrate are in this? Remember, nitrate is what we use. Nitric acid, that's HNO3. So we're talking about nitrate here. All right, so how many moles are in there? Well, we start with our formula, and this time I need moles. So we got to get rid of that V on the bottom. We got to get rid of that volume. So I'm going to multiply both sides by V. These are going to cancel out, and this is going to be my formula. Number of moles equals V times N. Plug in your numbers. Oh, be careful here, ladies and gentlemen. Notice what I plugged in for the volume. I did not put 500 milliliters. I put 0.5 liters. That will be a trap that is going to catch some students if you're not paying attention, okay? For this step, everything has to be in liters. It is moles per liter. And so if you don't convert it, you will miss the problem. This right here is a very simple, it's a 5, it just has 5 moles in it. That's it, okay, or 5.0 or whatever you want to take that to. All right, make sure that you are converting these to liters during this step. Let's take a look at one more example. This is going to be a little bit more complicated now. We have 15.6 grams of potassium hydroxide in a beaker of water. If its concentration is 4.7 molar, what is the volume of the solution in the beaker? So how much volume do we have? All right. Be careful here. That did not give you moles. It gave you grams. So the first thing we have to do is we have to convert the grams into moles. Well, what is this? That is potassium hydroxide. Potassium, which is K, hydroxide, OH. So this is our compound. We need to convert that into moles. So we're going to start by putting 15.6 grams over 1. Multiplying just like we've done before, straight moles to gram calculation. Grams goes on bottom, moles on top. Add this up from the periodic table, and we get that we have 0.278 moles of potassium hydroxide. All right, now it's kind of the same thing. Solving for volume is a little tricky. We're going to have 2 steps here. First thing I got to do is I got to get it off the bottom. I have to get it off the bottom. So I'm going to do what I did before, multiply. Now it's not on the bottom. Now in this step, it's really straightforward and simple to see. I just need to get rid of this M, so I'm going to divide, and that cancels out, and that's what it leaves my volume equal to. Plug in 0.278 divided by 4.7, and we get 0.059 liters, or if you wanted to, you could say it's 59 milliliters. Okay? Either way works. All right, so that was the first part. We're going to practice with that in class. The second part of this is dilutions or dilutions. I'm going to dilute something. Well, what does that mean? Well, when you dilute it, You are adding solvent to the solution to reduce the concentration. You're making it weaker, okay? A lot of times we will buy, as a chemistry department, we'll buy like really strong acids or things, knowing that we're not going to use them that strong. We're just going to dilute them. We're going to make them a little bit weaker so it'll last longer, basically. Okay? When you dilute a solution, this is important. What does not change is the amount of solute in the solution. In other words, the amount of stuff in there. I can add water to it, but I'm not changing the amount of stuff in there. Okay? Now the formula, really straightforward, really simple. Okay? M1V1 equals M2V2. You might want to write this down in your notes. The M is the molarity, the V is the volume. It's the same M1V1 that we were working with earlier, same M and V, okay? So you might want to write that down, draw some arrows and point that out so that when you look at your notes later, you'll remember that. So let's jump right into some example problems. These are really simple and straightforward. There's one tricky part you'll have to pay attention to. Notice it says if you add 50 milliliters to a beaker that has 200 milliliters, what's the new concentration? Okay, so we got our formula. We want concentration, so I'm going to solve for that second M, that second concentration. This is what I get. Now when I plug this in, please pay attention here. You start out with 200 milliliters and you add 50 to that. The new volume is not 50, it's 250. Please pay attention there. Okay? Make sure you don't get trapped by putting a 50 down here on the bottom. So what's my new concentration? 2.4 molar. A good way to check yourself, I added water to the beaker. The molarity should go down. The concentration should be weaker. Hey, that rhymed. Hee hee. Let's take a look at the next example. How many milliliters of water must be added to a 150 milliliter stock solution? Don't be thrown by that word stock solution. That's what I was just talking about. We buy them really strong. We buy a stronger stock, and then we dilute it to what we need. Okay? Same thing starting out. This time, I'm wanting volume. I'm wanting how many milliliters. So I'm going to solve for V. Get that by itself. Oops, my line crossed out incorrectly. My bad. Should cross out the two M's right here. So this is what I get. V2 equals M1V1 over M2. I'm going to plug in. Guys, one other thing I want to point out. Notice that I don't have to convert this milliliters. I did before, and if you wanted to now, that's fine. But you don't have to here. Whatever you're comfortable with. Okay? Plug this in. I get an answer of 750 milliliters. The question said, how many must be added to this? Well, in order to get it to 750, I need to add 600 milliliters of water. Now, I know that went a little fast, so when we come into class tomorrow, you're going to be practicing with this. Be sure you're asking me questions. Make sure that you're understanding this. The math is really simple once you understand some of the concepts. I'll talk to you guys later.